Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutewa Sos Ukobela Wemets. And without any further ado, let's look at these questions that we have here. Okay, so we have question 5 on electrostatics. It says 3 charges Q1, Q2, and Q3 are placed at right angles to each other as indicated in the diagram below. Then we can see the diagram like that. 5.1 says now define Coulomb's law in words. So this is how we are supposed to define Coulomb's law. We say the magnitude of the electrostatic force exerted by 2 point charges on each other is directly proportional to the product of the magnitude of their charges and inversely proportional to the square of the distance between them. Right. Now 5.2 says calculate the magnitude and direction of the force of Q1 on Q2. So the formula that we are supposed to use there, since we are looking for the magnitude of the force between 2 charges, is F is equals to K, Q1, Q2 over R squared. But before we can make use of this formula, I need you to have some pointers here. I need you to note something. Whenever we are working with this, we must make sure that our charges are in terms of coulombs. If we are given microcoulombs, then we need to convert this by simply multiplying by 10 to the exponent of 6. If we are given nanocoulombs, we express this by multiplying by 10 to the exponent of -9. So now you do understand the nanocoulombs are way much smaller than the microcoulombs. Now again, another necessary conversion, if we are given millimeters, we need to convert only our distance always to meters. So millimeters to meters, we have to divide by 1000. If however we are given centimeters and we need to convert to meters, we need to divide by 100. So make sure you note this necessary conversions here, because they will definitely come in handy when you start to answer those questions. Okay, so now let's go back to the formula. We have our K is 9 times 10 to the exponent of 9. Then our Q1 charge 1. Note again, if we have a negative, you do not substitute the negative into the formula, right? When it comes to using this formula here, we do not substitute any negative signs. The negative there is only telling you that this Q1 here will be attracting with Q2 since they have unlike charges. So unlike charges attract and then like charges repel, right? So, but then when it comes to substituting here, we only substitute the magnitude. So that's 8 times 10 to the exponent of -6. Remember, we converted. And then the Q2 has to be written as 2 times 10 to the exponent of -6. Now, what is the distance between these 2 charges? That's 44 millimeter. But then we're not going to write that one because, remember, we are not looking for the distance in terms of millimeters, but then in terms of meters. So that's 44 divided by 1000. And then square that. Now, at this point, you just need to grab your calculator and punch everything exactly as it appears on your screen. So that's 74.38 newtons. But then remember, we must also indicate the direction. Now, this is a magnitude and direction of force Q1 on Q2. So we want to know the magnitude and direction that Q1 exerts on Q2. Now, because Q1 here is negative, we do understand that it will be exerting an attraction force towards Q2 here, pulling Q2 where? Upward. So in other words, we can say that Q1 is exerting an upward force on Q2, pulling it upward. So we need to say here, upwards. That's our direction. And then just like that, we have our 3 marks. Then 5.2.2 says the magnitude of the resultant force of Q1 and Q3 on Q2, right? Now we have already calculated that Q1 exerts a force of 74.38 Newton on Q2. But then looking at this part here, we can see that the magnitude of the charge of Q3 is similar to the magnitude of the charge in Q1. right? And then also the distance between these two charges is the same. So that means if Q1 exerts 74.38 newtons on Q2, then definitely Q3 will exert the same magnitude of force because these are identical charges, right? So that's 74.38 Newton. And also we have the same distance. So that means they will be the same there. Now, having to use our Pythagoras theorem to find our net force, this is what we have now. So all we're going to do now is just close off this part so that we form a right angle triangle. So let's close off here. And then we have our right angle triangle like that. So this will be our resultant. Now, to calculate our resultant, we do understand this is f rest square according to a Pythagoras theorem. Then let's say f of Q1 square plus f of Q3 square, right? So f of Q1 is defined as the force that Q1 exerts on Q2, and f of Q3, that's the force that Q3 exerts on Q2, right? Then in order to calculate our f rest now, we need to square this. So our FQ1 was 74.38, and then we square that. And then also this one needs to be 74.38, then square that, right? Now, having to calculate all of this, we find that our resultant force or our net force is 105.19 newtons, right? So you can say it's the resultant or the F net, right? Then 105.19 newtons. Right, now 5.2.3 says the direction of the resultant force of Q1 and Q2 on Q1 and Q3, meant to say on Q2. So now we know that the trig ratio that we apply for that one is tan. So that's tan theta. And then we're going to have our y value and then over our x value here. So the y being the vertical magnitude and then the x being the horizontal magnitude. So this will give us 74.38 divided by 74.38, which is obviously 1. So we have tan theta is equals to 1. Then obviously our theta here is supposed to be 45 degrees. So that's why it was even that 1 mark. So all you needed to do is just come to 5.2.3 and just indicate that your theta is 45 degrees. That's all you needed to do. So there was no need for you to show the rest of the calculation for that one because it's only a mark, right? Then 5.3 says Q2 is now replaced with a charge of -2 nanocoulombs. Explain how this charge will influence 5.3.1. The magnitude of the net force on it. Only use increase, decrease, or remain the same. Now, if they are replacing this Q2 with a charge of -2 nanocoulombs, right? We do understand that now they are using a smaller charge, right? If they are using a smaller charge, remember, we say, according to Coulomb's law, we say that the magnitude of the charges is directly proportional to the electrostatic force. So if they are using a smaller charge, then it's obviously that the magnitude of the net force acting on it will decrease. So the answer here is supposed to be decrease. And now 5.3.2 says the direction of the net force on it. So what will be the direction of the net force? Now we can see that not only did they introduce a smaller charge, but then they also changed the what you call the charge on that Q2. So now it is negatively charged. So if it is now negatively charged, what are we going to experience here? We're going to experience a repulsion force. So this Q2 will now be repelled to that direction. And then also due to Q1, it will also be repelled down there, because now this will be a negative and a negative, so like charges repel, and also here it's a negative and a negative, so like charges repel. So the direction of the net force right now will be in the opposite direction, right? So we can say now the direction of the net force will be in the opposite direction. So will be in the opposite direction of the initial direction. So in other words, because we found 45 degrees here, that means the direction of the other one right now has to be anti-clockwise like that, and then it will give us 45. If we say 45 plus 180 degrees, that will be 225 degrees, so something like that. But then all you have to say is that it will be in the opposite direction of the initial direction, right? And then that's how you were supposed to tackle this question here. And then please press the thumbs up button if you have enjoyed the lesson and then you have found it helpful. And then if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.